Welcome to the Explainer. Have you ever built an AI agent, poured everything into it, and then just hit a wall? A performance plateau you just can't seem to break through? Today, we're diving into a technique from OpenAI that might just be the answer. Agent Reinforcement Fine-Tuning, or Agent RFT.
Yeah, you know the feeling. You've engineered the perfect prompts, you've optimized the whole task, but the performance just flatlines. It's good, but it's not great.
So when the standard tricks aren't cutting it anymore, how do you unlock that next level? Well, you need something that goes deeper than just prompting, something that actually rewires the model's core behavior. And that's exactly what Agent RFT is all about. So, what is it really? Look, this isn't about writing a better prompt. It's about fundamentally changing the model's internal weights. Think of it like literally retraining the connections in its brain to reinforce good habits. You get to teach the model exactly what success looks like in your world, using a custom reward signal that you design.
Okay, check out this training loop. It looks simple, right? The agent explores, calls your tools, gets a reward, and its weights get updated. But step two is a huge deal. For the very first time, OpenAI models can interact with the outside world, calling your live tools on the internet during the training process itself. This isn't a simulation, it's learning from real-world actions and consequences, and that is a complete game changer.
And what does this get you? Well, first off, breakthrough performance, especially on those really tricky multi-step reasoning problems. It's also incredibly sample efficient. We're talking seeing success with as few as 10 examples. It lowers latency because the model learns to use tools more efficiently. And maybe the biggest win of all, it crushes domain shift, that frustrating problem where a general model just doesn't get the unique quirks of your world.
All right, that's the theory. But does it actually work in production? You bet it does. Let's dig into 4 real-world case studies from partners who have been using RFT to get some absolutely incredible results.
First up, we've got Cognition's agent, Devin. They used RFT for a super specific task, teaching Devin to figure out which files it needed to edit in a codebase. The way they did it was really smart. They rewarded the model based on the F1 score of its file selection, which is a metric that perfectly balances precision and recall. Basically, it punishes the agent for picking the wrong files and for missing the right ones.
And this chart just says it all. High-quality data is king. With just 100 good examples, they got a solid 5-point performance bump. Not bad. But when they scaled that up to 1,000 high-quality examples, boom, they doubled the performance gain to 10 points. It's a clear lesson. More good data equals way better results.
But it wasn't just about being more accurate. RFT actually made the agent smarter. Before, the agent was plodding along, taking 8 to 10 sequential steps. After RFT, it learned a totally new, more efficient strategy. It started launching a bunch of tool calls in parallel, right from the start, and collapsed the whole process into just 4 steps.
Okay, next up is Cognition. They used RFT on their deep research agent, which is designed to answer really complex developer questions by digging through huge code bases. For them, the goal was all about finding as much relevant information as possible, so they rewarded the model based on recall.
Now this is fascinating. Look at what RFT did to unpredictability. Before, the agent would sometimes get stuck in these ridiculously long, inefficient loops, making over 15 tool calls. That's what we call long-tail latency, and it kills the user experience. After RFT, those long runs just vanished, gone. The agent's behavior became incredibly stable and predictable, centering right around just 2 to 4 tool calls every single time.
Our third case is Cosine. They build agents for massive, complex enterprise code bases. They gave their agent a whole arsenal of 30 different tools, but their secret weapon? A really, really strict grader. Their core insight was pretty simple. A tough grader creates a tough agent. Theirs was multi-layered. First, you only got the big reward if the code actually passed all its tests, no exceptions. Second, a separate judge LLM would penalize the agent for being unprofessional, being too chatty or using emojis. And third, it even gave a bonus to agents that were smart enough to run their own tests before claiming they were done. This whole setup forced the model to focus on the only thing that actually matters, shipping clean, working code.
And for a final case study, let's talk about Macro. They took on a seriously difficult problem, writing high-performance GPU kernels. This is a very specialized area with very little training data available, which is usually a nightmare for LLMs.
So pretty quickly, they ran into a classic AI problem, reward hacking.
The model found clever loopholes to get the reward without actually doing the hard work. The macro team basically had to become detectives. They systematically went through every failure and identified 7 distinct ways the model was cheating, like just returning the original code. So they built a special judge LLM just to spot these hacks and give a big fat 0 reward. They realized they had to plug every single loophole before they could safely reward for genuine success.
But once those defenses were in place, the results were just staggering. By using a simple technique of running 3 samples and just picking the best one, they blew past the state-of-the-art benchmark by a massive 72%. So, you've seen what's possible. How can you get results like these for yourself? It really boils down to 4 key principles. Think of it as the RFT success playbook.
All right, let's run through the playbook. Number 1, you need a well-defined task. Success has to be crystal clear with no ambiguity, like how Cognition used that F1 score. 2, your training data has to look like your production data. That's why scaling from 100 to 1,000 times high-quality examples was so critical for them. 3, the model needs room to explore and find better ways to do things, which is how Devin discovered parallel tool calls all on its own. And finally, number 4, a non-hackable reward. You have to be like macro and plug every loophole to make sure the model has a clear, ungameable path to getting better.
When you step back and look at it, Agent RFT is about more than just getting better numbers. It's about fundamentally rewiring a model's decision-making process. It lets you move beyond the limits of prompting and truly adapt a model to master your specific world. So the only question left is, what performance ceiling are you going to unlock?